All right, so we're going to talk about solving a systems of equations by graphing. And we've kind of alluded to this, but first we need to get both equations into slope-intercept form, aka y equals mx plus b, because that's how we know how to graph them, right? And then you graph both lines. And then from there, you find the point of intersection. So we find the point of intersection. The answer will always be an ordered pair. So forever and ever, the answer to systems of equations will always be an ordered pair. And you need to graph as many points as possible. Okay. So graph as many as you can, because again, we need to extend it as far as we can, so that way we can accurately find the point of intersection rather than just guessing. Okay. And just to reiterate, the point of intersection is where both equations, well, where both graphs meet. Okay, and it'll be obvious when we get there. So I recommend using the line tool in Kami, and I'm going to do that as well in here, the line tool. Okay, but not right this second. All right, so good news is both of our equations in example 1 are already in slope-intercept form. Okay, so all we have to do is graph them. Some reminders that this is your b value, and this is your slope. Maybe thinking, but Miss Myers, there's nothing there. Remember, there's an implied 1 here, and that 1 is really over 1. So we start up here at +3, and we go up 1 over 1 to the right. And we graph as many points as we possibly can. And then we go down and over until the graph ends, okay? And then we're gonna draw our line. Again, I would probably use I might move that up a little bit. I definitely want to move that up a little bit. I don't know if I can, but it doesn't matter. Okay, so that's that. And now we're gonna do the other one. So figuring out where the other one crosses, again, this is your y-intercept, this is your slope. Now it's a -1 over 1. So we're gonna start here at +3 again. And now we're going this way. Okay, up 1, down 1, up 1, down 1. Up 1 over 1. And we're gonna connect that line. I don't know why it's starting over there. That. OneNote is not as. Oh, now I erased it. Okay. Anyway, so there's a line there. Try to get it on your dots. Mine are a little off, but that's okay. So our point of intersection, right? Our point of intersection is right here. Right? So what is that ordered pair? Well, that ordered pair is 0, 3. Okay, 0, 3. It won't always be as obvious as that. So we're gonna do the next one. I actually want you to try the next one. So start by just graphing this one and then graph this one. Okay, so I'm gonna do it in pink and teal. So start by graphing the first one and then graph the second one, and we'll check in a moment. So real quick on the going down, it's make sure you count. So it's 1, 2, 3, 4, 5, 6 is there. Just be careful where you put that. All right, so hopefully this is what your first line looks like. It's going up 3 over 1 in the positive direction, starting at -6. And now we're gonna go start on the second graph. All right, so now this is what our two lines look like. And then our point of intersection is right here. So remember, it's where they both cross. And that point is, it looks like 3, 3. Okay, so that's our point of intersection. All right, but there's a couple of other things that we need to keep in mind. There's special circumstances. All right, so some special circumstances. If our lines are the same, so if our lines are exactly the same, we are going to have infinite solutions. Okay, so they may look different, but they're gonna be, well, they're not gonna look different. They're gonna look the same, but we can't tell that until you'll see. If our lines never cross, if they are parallel to each other, we're gonna have no solutions. Okay. So remember our first step was that we needed to get both equations in a slope-intercept form. So looking at the back examples, they are not in slope-intercept form, so we have to solve them first and then graph them. So let's do that right now. Okay, so this one, so we have 5x plus 3y equals 9. Remember, we want to get y alone. So I'm going to subtract 5x on each side. And I get 3y equals negative 5x plus 9. Again, we want to get y alone. So we divide everything by 3. And we get y equals negative 5/3 x plus 3. Okay. I want you to solve the second one. So try to solve the second equation on your own right now for y. Try that right now. All right. Hopefully you got positive 2/3 x minus 4 because it was a negative 2x divided by a negative 3, so it's a positive. So now let's graph both of these. Okay, so start graphing the first one. We'll graph this one first. Okay, and we'll check it. Okay, so hopefully your graph looks like this. You were able to get 4 points on. Okay, then we're going to start with the next one and start graphing that. Okay, so pause right now and try to graph that one. All right, so hopefully you got that they crossed right there at 3, and then it's really -1, -2. Okay, so it looks like it's 3, -1, but it's really 3, -2. All right, I want you to try example 4 on your own. So you need to get this into slope-intercept form, so solve for y, and then graph both of those, okay? And I'll check in, but try doing this one on your own. All right, so if you notice, when you solved it, you got y equals 4/3 x minus 4, which is the same as the other equation. So if you want to graph these, you should have gotten overlapping lines. So if the lines are the same, we have infinite solutions because they're going to cross everywhere. Okay, so my answer is infinite solutions. All right, so let's do the next one. Okay, so do example 5. I want you to solve them both for y and then graph them. Okay. All right, so hopefully for the first one, you got 3x plus 2. And we can graph that now. And it looks like this. And now we're going to work on the second equation, which is this one. Looks like it's a little bit more detailed to solve, so be careful. So you needed to subtract 8 first, then we got -6, and then it's just like normal, subtract 3x. What you need to keep in mind is that this is a -1 here. Okay, so then you divide everything by -1, and then we got 3x plus 6. So let's start graphing that now. So pause and graph that. Okay, so when you graph it, it looks like that. What do you notice about those? Do you think they are ever going to cross? Think they're ever going to cross? Well, here's a hint. Let's look at their slopes. They have the same slope. So no, these are never going to cross. They are parallel lines. So then the answer is no solution. Okay, so if they never cross, they're parallel, they are no solution. All right, make sure you ask questions in class.